All right, so yes, I am Dave Gutkowski. I've been a NEARA member since 2007 when I stumbled across a cool collection of boulders that I called Council Rocks because they looked like a great place for Native American council meetings. Found them in 2004, didn't know what they were about until 2007, but let's get into it. So yeah, Ceremonial Stone Landscapes, which we've been talking a lot about today, as desktop planetarium models. Now, you know, we look at these ceremonial stone landscapes, the CSLs, and you'd love to see what they line up with. Well, I'm going to show you how to make that happen. So my training ground was the Council Rock site in northeastern PA, Bear Creek Township, just east of Wilkes-Barre. And this is a picture of myself back from 2004. When I was up on the mountain, I just kind of wanted to give you an idea of what it looks like. The view is gorgeous from up there. You can see for almost 50 or 75 miles out to the west. These are the stones themselves. Again, I called them Council Rocks. This is my very second visit up to the site. My friend Nancy Hadsall, I asked her to come up with me and check them out to see what she thought of them. And we came up with the name Council Rocks, a great meeting place for native meetings. This is what they look like from the opposite side. Just wanted to kind of name the stones. The one on the right I called the bird stone. The one in the middle I call the whale stone, and the one at the far end, the cat stone. If I go back a slide, you can see why I call that the cat stone in the front. Kind of has an ear sticking out and a nose off to the right. It looks the same from the other side. It's kind of cool. But from the air, this is what they look like. I got a drone in 2014, 2015. So the cat stone's on the left, whale stone in the middle, bird stone on the end, and altar slightly uphill. The three of those are in a perfect line, and when I mean perfect line, you'll see that in a slide or two. Council Rocks winter solstice. So this is early methods for discovering and analyzing a winter solstice alignment. Now the purpose of the talk I want to give today is not to tell you so much about Council Rocks, but about how to put any CSL into a planetarium model because it's so useful. There's so much we're going to learn about this, and I'd love to help anybody with that in the future. So my early methods were to, when I figured out that these stones must be something special because of a book called New England's Ancient Mysteries, I got in touch with someone named Paulie Midgley, who then put me in touch with Fred Martin. And Fred asked me if these lined up with the winter solstice sunset, and at that time I really didn't have a clue. Fred said I should look through the curved part on that bird stone, past the cat stone's nose, and I might see a winter solstice sunset. Now, unfortunately, winter solstice that year, 2007, was very cloudy. But I wanted to point out how straight of a line these stones are. They're actually a very perfectly straight line. You can stretch a string and it touches all three of them. And as field researchers, I want you to be on the lookout for things like that. I mean, we can see stones in a field. I've seen plenty where they're lined. You see two stones that are sort of lined up, but they're rounded, etc., etc. If you see a feature like this, you know that there might be something important to it, that it's not just a natural occurrence. So this was December 31st, 2007. As I said, we had cloudy, snowy weather for about 2 weeks. I couldn't get up there. But on December 31st, New Year's Eve, I got out of work as fast as I could, drove to this place, got up there just in time to catch a winter solstice sun coming down, near winter solstice, and setting right into that curve on the bird stone past the beak. Or past the cat stone's nose. Now I've been an amateur astronomer for a couple of decades, and I knew that if I had the date and time of my photograph accurately, I could use what are called ephemeris charts to look up exactly where the sun was. So whenever I do take a camera out in the field, and I advise everyone here, if you use a separate DSLR, make sure it's set exactly to the minute and second, so you can do that kind of reference work. So I use a site for my ephemeris tables called Horizon Software. It's on NASA's Jet Propulsion Lab's website. I'm sure these slides will be available later if you want to be able to look that up. But when I plugged in the data for the photograph I took, it told me that the sun was at 238 degrees from true north, 238.4426 exactly, and it was just about setting. The altitude was near zero. So I thought I'd go back in time and see when the sun would have been there. So this was December 31st. I wanted to see when the sun would have been there on December 20th, or 21st. So I went back in the same charts, and it told me that would have lined up in 1825 BC, which kind of gave me a clue that this site might be 4,000 years old. Now again, I'll say this was my first pass. There are other considerations I have about that now, but that'll give you some idea. You can use that kind of research to tell you how old something is by when one thing lines up now compared to when it would have lined up long ago. So again, the winter solstice alignment. So then I started looking for an equinox. In 2008, the year after that, that was the end of 2007. So 2008, I'm out there looking for an equinox alignment, and I noticed I think I have a pointer here. Yep, this cutout in the catstone. And by the way, that's the other side of the catstone. I love this stone, but it's about 25 tons, and it's got a cutout in it. And I noticed that cutout is not parallel. The strata in the rock kind of comes up at an angle. You can even see a natural break in the rock happening. There's a natural crack there forming a perpendicular angle. The angle of this cutout was different. It wasn't natural. It told me that maybe that was man-made. So I looked around, got behind the stone, over where that X is, stood there, and I noticed when I looked through that opening from that angle, the altar stone could be framed just like that. So that told me that this might have some significance. It might be an equinox alignment. So I took out my compass, and sure enough, two early important observations were the compass showed me that it was just a little bit south of east, which is about where it should be because the sun's going to rise in the east but then come up. I'm looking uphill. And then second, it was very easy to figure out how to see it properly. Like I didn't need a marker on the ground or anything. All I had to do was frame the two puzzle pieces together. And I'm going to show the later work, actually just within the last several years, how I've refined that. And it's amazing how precise this alignment is. But that first year I was out there, again, cloudy weather, never got a picture of the sun anywhere near that opening. But I got the sun somewhere down here. I got some outside pictures. And again, I used those ephemeris charts, plotted it on graph paper, and estimated that the sun would come up into that opening the following year on March 17th at 8:22 in the morning. And sure enough, boom, there it was. So it's a fantastic sight to see. I know many of you have seen this as far back as 2012. I took these, presented at a NEARA meeting, but I wanted to kind of refresh how that early work was done. So back at the time, I thought I could look up the dating of the equinox line by going back in those charts and using the sun's position, and it told me that based on the position of the sun, 2010, it would have rose on equinox in 125 BC. Gotta say I was wrong, but at the time I thought, first pass, that's what I thought was going on. And I'll tell you why in a little bit. But again, there's that image through the crack. The sun comes up here on March 17th. Now, I wanted to know, when you look through this opening, in order to frame that altar stone right inside this opening in the bigger stone, you've got to be in just the right spot. If you move forward a few inches, that's what happens. The altar stone seems to shrink because the opening is larger. You're closer up to it. Just like if you hold your hand at a distance and then move it closer, the background gets bigger. And if you stand too far back, just a few inches back, oops, on this picture, the stone is perfectly framed in the camera from where the camera is, but from just a few inches back, the altar stone is too big to fit in the opening. So you know that there's a very limited amount of space you can move forward and backward. It's actually about 10 centimeters or 4 inches, front to back, 2 inches each way, 2 centimeters each way. But that alignment, when you stand in the right spot, that's what you get. I was also curious about this horizontal opening up the top and the vertical. I thought I could measure, that's like an XY axis. I could measure how far up or down or how far left or right I can stand. So a couple of years ago, I took a meter rod out. I was with Eva Gibovic, also a NEARA member. And even I measured it. At 107 centimeters above the ground, that opening is just about where you'd want it to be. 108, it's covered up by that part of the catstone. 106, it's a little bit more open. 105, it's a little more open and almost unusable. So what I gathered from that is that you have about 2 centimeters of space up and down, and similarly 2 centimeters of space left and right, which works out to about 3/4 of an inch. So 3/4 of an inch, I wanted to do all the math on it because I'm a math guy, engineer. So I strung a tape measure from the corner of the altar stone all the way back to the tripod. Came out to be 52 feet, 2 inches. Wanted to convert it to centimeters because that's what I was working with in the other dimensions. So that's 15.9 centimeters or 15.9 meters, 1,590 centimeters. Again, there's the line. So picture this like a big stone telescope. You're looking through the eyepiece here, up past that altar stone. All you've got is 2 centimeters of space, left, right, up or down, and 4 inches back and forth, and somewhere in a pocket here, next to the microphone. I've got a piece of 3/4 inch tubing that's 4 inches long. That's all you get when you're at that stone, when you're at that alignment. It's extremely precise. So it's a really cool piece of machinery, if you will. And it told me that this was most likely very intentionally designed. Source of intentional and intelligent design. So the next level up for this was to do a desktop planetarium model. I had always dreamed of being able to put the stars behind this. So I didn't have to worry about cloudy days, foggy mornings, etc., etc. So I have a web page up on academia.edu where I share information with other researchers around the world, really. And I got connected, a guy by the name of Bernard Fisher from Indiana University contacted me. He does 3D work, mostly in Rome. He's done recreations of the whole city of Rome. They're really fantastic. But we conversed a little bit. I told him what I was up to. He put me in touch with a guy named George Zotti. George is at the Ludwig Boltzmann Institute in Vienna, and he co-developed free desktop planetarium software called Stellarium. So George has written subroutines that let you put your own landscape into Stellarium. So we worked together. I actually presented this for NEARA about 1.5 years ago. So what I had to do is take the camera out, set up a tripod exactly where that alignment was, and then rotate the camera around several times, up, high, low, etc. Put about 200 images together, stitched them into this one photo, took out the horizon, made it all blank in the background, and then put it into the program Stellarium. When I did that, I was able to dial in a date, 2009, March 17th, the time of the photo, and I sped the time up a little so you can see what happens. The sun comes up right here next to the altar stone, then comes up right into that opening, the same as it did on the photograph. So the beauty of this is you can sit at home anywhere. Once you have your CSL in a digital form, you can go back and watch anytime, make the sun go across the sky faster, see what comes up at night, see what constellations rise, what stars rise, what planets come through there, etc. It's absolutely amazing. You can look at other features in the area in case there's something you missed. You can start it, stop it, speed it up, click on any object and get all the information on whatever you clicked on. That's Betelgeuse. So it's really a fantastic, fantastic tool. Now, as I said before, March 17th is when the sun comes up here, and the equinox does not change over time. I was so disappointed to find that out. That equinox actually happens here when the sun crosses the celestial equator. So it never moves. 2010 it's there, 100 AD it's there, 5000 BC the sun will be there on that same line unless there's a crustal shift. But I was kind of disappointed to see that because I wondered why would it be over here. But yet, as I said, Stellarium gives you all kind of information on any object. When I clicked on the sun, it said that there was 12 hours and 11 minutes of daytime. Conversely, only 11 minutes 49 of night, so that's not equinox. Like we know equinox is equal day, equal night. So I thought, oh no, what about the corner? Is the corner going to be even worse? So when I put the sun in the corner, it turns out there's 12 hours and 2 minutes of daytime and 11 hours and 58 minutes of night, which was like, wow. So maybe this is actually equinox, like equal day, equal night, rather than what we call the astronomical equinox, when the center of the sun crosses. So I had to do a lot of research on that. Found out, yes, equinox means almost equal day and night. It's common wisdom, but it's not entirely accurate. If you go to timeanddate.com, there are articles about it where I pulled this one up. But what I really loved when I read this article on timeanddate.com that explains the whole mechanism, why the sun isn't exactly 12 hours on equinox, it says that the approximate date of equal day and equal night depends on the latitude. And our latitude that we're at, 41 degrees north, March 17th, September 26th, the same day that Council Rocks was, in my opinion, built for, incredibly built for. So for someone to put this stone structure together and have it be that accurate, that it's actually within 4 arc minutes of space when you're looking up through that opening, and have it be at the day of equal day and equal night. To me, it was amazing. Again, March 17th, September 26th. Now I also looked, another jewel discovered via Stellarium, using Stellarium to find yet another fascinating built-in feature that I didn't know was there. I talked about the cloudy days when you can't get a picture through something, through any CSL, not just this one. But I always wondered about this vertical line and horizontal line. If people gathered, if nations came together to gather here thousands of years ago, and they wanted to see that sunrise, they waited for it and it was cloudy, well, wouldn't it be handy to know if the sun was down here, how long you had to wait, or if the sun was over here, if you're in September, it goes the opposite direction. You know, if that was a timing mechanism. Turns out it is. The sun rises here on March 6th, which is 11 days before equinox, equal day, equal night, and it exits on March 28th, 11 days later. So I thought, fantastic, just as I had theorized, it was 11, you know, it's an equal number of days, 11 days before, 11 days after. I thought that's way useful, and little did I know how useful it was. An astronomer by the name of Ken Leonard, when I was sharing this with someone else, Ken Leonard jumped out of his chair and said, "Do you know what you have here?" And he called it an intercalator, and Ken spoke way over my head, so I can't really explain it to you all. But as it turns out, a lunar year as indigenous people would use, Native Americans, other cultures, count the moon cycles. 12 moon cycles will take you from one year to the next, just about, pretty close. But it's actually 354 days. It's because it's 12 months times 29.5 days per lunar cycle. We have a solar year of 365 days, which is 11 days different. The technical term for it is called epoch. There's an 11-day difference in the two cycles, and somehow this mechanism, this site, is able to reconcile those two and let someone know when to add in an extra month to their calendar every 3 years, or an extra day to the calendar every 4 years if you're using solar. So this was another find that I never ever would have known about until I was able to put my own CSL into Stellarium and do this kind of research. It's actually remarkable. And if you want to know more about that, there's another NEARA member named Dave Brody. He wrote the Knights Templar series of books. Novel number 15, Solomon's Seal, or Solomon's Sigil, was about Council Rocks. So he does a pretty good write-up about that equinox marker. I like it. But some of the ancient cultures that used lunar calendars, China, Sumeria, Babylon, Egypt, and then the European ones that use the solar calendars, any two cultures that were together would have been able to use Council Rocks as a marker. So winter solstice at Stellarium is a lot less remarkable so far. I mean, there's more work to do. But I did the same thing of stitching together a panorama from where I took that photograph, took all the sky out of it, plugged it into Stellarium. I put in December 31st, 2007. And you can watch the sunset, come right down into that opening.
Just as someone's out there photographing that day.
We have an echo?
I don't know where that's coming from.
I don't know. Second microphone?
Sun setting right on the capstone.
That's your voice.
Oh yeah, how about that? I'm talking on there. Anyway, the sun sets right on the tip of that catstone from the equinox. I hope I didn't say anything bad on there. So I backed up to 1825 BC on the actual solstice, solstice, not equinox. And the sun sets exactly in the same place, 4,000 years and 11 days before. So there is some significance to that. But I will say that unlike the equinox marker, which has a nice three-dimensional perfection, the only dimension line I'm aware of here is this straight line here, which does point right towards the solstice. Don't get me wrong, it's nothing bad. But it's just that I don't have a precise place to stand. Maybe I should be standing looking through this part, the curve, maybe right along the front edge, watching it hit on the nose. I'm not sure. And it doesn't make a lot of difference, except in the dating, how far back you have to go in time for the two things to line up. So that's, again, it's another tool to use for things like that. So the next thing in CSL search work, if you're going to do this kind of work, I would highly recommend this really cool panoramic camera called the Insta Pro or Insta Pro 2. Myself, Tom Elmore, who was supposed to be here this afternoon, and Eva Gibovic, we formed a little team called the Triad of Technologies Tom does above ground LiDAR, Eva does GIS mapping, and I do the astronomy work. So we were the triad of technologies. We were invited to come up to Colgate University to give a presentation at a symposium that they canceled due to COVID. But when we went up there, we met Joe Aiken, the Planetarium director, and Joe was kind enough to loan me this cool, instantaneous panoramic camera, which has 6 spherical lenses around it, and you can set it up on a tripod, and with the push of one button, you get a ground to sky, perfect 360 panorama. It's fantastic. Now you still have to do some processing when you get home, but you don't have to take 200 pictures on a tripod. It's really, really cool. So I took that out in the field, set it up here. This is looking near what I call the white boulders. There's big white quartz conglomerates in a meadow up here. Nice mountain range out there. Actually set this up so you can look past these white boulders and out to that distant mountain range. I wondered what might happen there. So I took a lot of different pictures. Now the white boulders too, that's Tom Elmore, who couldn't be with us today. But the white boulders are white quartz conglomerate. They're from the Pottsville conglomerate geologic layer. They actually come from this ridge line over here, about 3/4 of a mile away. They may have been carted here, or they may have been glacial erratics that were dropped nearby. They were not dropped in place here 12,000 years ago because we've done some OSL testing, which I know Vance will report on later. But this particular one stone right here we had tested, and it tested for somewhere about 2,000 years ago that was placed, not dropped by a glacier. So those are the white boulders. There are about 8 of them. They go, the 2 bigger ones are in a line this way. There's a parallel set running up here. And then there's another set here that connect up with a shaped napped wedge of sandstone. So they do make nice parallel lines, and I got all different kind of configurations with that InstaPro camera. The napped wedge of sandstone is a little sandstone or quartzite actually. It looks to me almost like a napped axe, except it's a lot bigger. It's about 18 inches tall, about 30 inches long, has a perfectly pointy edge on the front, which you can see the napping on it, that has been reworked several times to get it down to a point. And that wedge points right here, right toward that big white stone. It's about 60 feet away from that big white, the same one that's in this picture here. So that wedge is pointing here, and I thought, well, maybe that's aligned with the summer solstice sunset. It's about in that general direction. And I'm all curious about this, how close it is to an equinox. So in order to find out, oh, by the way, this line here, pointing toward the west, if you stand down there between those 2 stones, just beyond them, and look up, that's the March 17th sunrise. So again, this tells me that people set this up to be a marker for that equal day, equal night date. So what I'd like to do now, how are we doing on time?
We got about 10 minutes.
Good. So I'd like to actually open up Stellarium so you guys can see it live. These panoramas, or these landscapes that I put together, I only put together within the last 2 weeks. So I have looked at them about as much as you will be looking at them. When I stitch a panorama together, now this is, if I can get this to move, yep, there we go. This is the landscape up near the wedge. And this is what you can do with Stellarium, pan around. So there's that wedge, there's the white boulder. I didn't take out all the horizon from this picture yet because I was doing so many other ones. It takes a bit of work to get them together. But I did have a picture of the sunset right there. And all I do is pretty much get that sun right where it matches up with the picture that I took, a couple more minutes. Take a reading on the sun's position, and then I rotate that landscape into Stellarium so it's perfectly lined up with the sky. And once that's perfectly lined up with the sky, then we can go back to something like this, the alignment I was looking at, and put in a date. Let's get that back to, I'm going to go before sunrise here, before a projected sunrise. So I'm going to go to, solstice. And watch the sunrise. And I know what happens, so I'm not going to do a spoiler alert. But there we go, sun coming up to the left of that stone. And boom, right over the top of it. So how cool this is, for all the years that I've been working up here, I've never taken the time to go over there on summer solstice morning and get that shot, I will this year, because I know when it's going to happen. So this, again, this tool is amazing. You could see, besides sunrises and sunsets, you could watch planets go by, constellations. You can do just about anything you want.
That's not for a past alignment. That's for.
Yeah, that's for the current one. If we do a past one, let me just type in a date here. I think that was somewhere around, well, that's close enough, about 2,000 years ago. You'd have to, first of all, find out when solstice was by checking out the movement of the sun. What we want to do is advance the calendar a little bit to get the most, not to do the months though, do the days to see when the most northward movement of the sun is. Yeah, the sun's kind of making a little bit of a loop here. Yeah, so you want to get generally the most westward movement, which is somewhere around there, I guess. 628, 29. Get back down to the marker. And it looks like we're going to hit it. Yeah, there we go. So even in 0 AD, I mean, you can play with this as much as you want. You can go back thousands of years or you can go forward thousands of years and get all kind of information and never have to worry about a cloudy or rainy day.
I am curious, you adjusted for the latitude for the equinox, but you didn't do that for the solstice? Is there something I'm missing?
For the latitude? No, the latitude's plugged in. That's part of the, when I input a landscape into Stellarium, you've got to put the latitude and longitude in. Picture already has it, yeah. Yeah, there's a line of code that you have to enter in, but that's all in there. And let me see too, I wanted to show you the other White Boulder sunrise, just to show you how that looked too. Yeah, so there's that same arrangement that I had the picture of. Use the keyboard again, it's a little bit easier. Yeah, 317, and get the brightness up there too. Oh, we got it, minimum brightness. Come on, there we go. Yeah, it's great though. If you want to see what the Milky Way lines up with, if you want to see what Venus lines up with, lunar cycles. I am not an expert in lunar cycles, but here we go, sunrise coming up.
Some structures line up with the rising of the Pleiades.
Yeah. And that's the kind of investigative work you can do. Yeah, there we go, 8 o'clock. Sun coming up right over that. So, yes, sir.
Dave?
Yeah.
So Dave, you know, we were talking about the distance from all these features, these CSLs, to get the right perspective, especially the sunrise and
Yeah.
two pieces coming here, with the cabinet and whatever. Did you use any kind of a probe to see if there's anything that tells you where it's staying? Like, is there a flat stone below the sod that is where
You know,
you're supposed to stand?
I'm always careful to not disturb too much ground if I don't have to, so I haven't dug up the sod. There may be something.
I wasn't inferring that.
Yeah.
That's great in respect, but I use a probe, like in cemeteries, stones fall over, you just take a rod.
Yeah,
a
yeah.
soft rod, and just poke.
Just poke and see what you hit.
If you find a consistent stop at 1 inch.
Right.
On the surface, you might find there's a platform where the person's supposed to.
Yeah, there might. I wonder about that one behind that from this other angle.
And there were transfer generations, and not everybody would look there would know.
No, not everybody would know it. Only, I mean, the ceremonial. I'm sure the shamans or sachems would have known what to look for. By the way, too, I wanted to point out the solstice line here, or pardon me, equinox line. So when the equinox sun sets here from this position, it doesn't hit exactly west, as it won't, because it's not. But the sun does land on this little peak of a mountain, which is about 40 miles away. I don't know if that has any significance. It may just be just an accident. What I was more curious about was that mountain over here. Now, I should say accident. That's probably on purpose as well. But that little mountain, that cup-shaped thing over here, on April 8th, I believe it is, the sun would come down and rest right into that little cup on the mountain. But I don't know any significance to any early dates in April, April 8th. If anybody knows anything, shout it out.
April 4th.
April 4th?
April 3rd and 4th, every 8 years, is when Venus and the Pleiades rise together.
Oh, really? Okay. Well, we probably don't have time to like scope that all out. But once you've got this, you can do anything. So it's really, are we just about out here?
Yeah, you're right on time. Right on time.
Fred,
One more question.
absolutely Fred, because if it weren't for you back in 2007, I wouldn't be here. So
There is a question: what is the definition of the equinox? And if you count days from between the solstices, it's a different way of defining the equinox rather than equal day and equal night.
yeah,
As a result, the alignment direction is not exactly east or west.
slightly different. Yeah.
It also depends on the speed of the Earth traveling around the Sun, which enables you to do some dating with it. There is a question of these competing theories of what's current in the culture, not in the astronomy.
Yeah, because the astronomy is a different thing. I mean, if you're measuring, as we do, the center of the sun crossing the celestial equator, that you can say that that's equinox, and yet by definition, it's not equinox. But you're talking about a third way then, counting the days between. Yeah, between the solstices. Yeah, there'd be another thing to investigate too.
In our measurements at King Philip's Rocks,
To keep what?
we measured what we think is the equinox sunset.
Right.
Upstate New York, and it's not due east, due west of the sunset.
Really? Yeah. Yeah, so there are a lot of theories. What I like is to have a tool like this that let you put your own CSL in, whatever your own favorite CSL is, and do that kind of work.
Gordon Freeman, who's a professor at the University of Calgary, and I think he spoke at NEARA. He studied what they call Canada Stonehenge, which is a medicine wheel in Alberta. And he found that for the equinox alignment, it was the same date that you found.
Oh yeah?
Yeah, Dave. It was the exact number of equal hours of darkness and lightness, which is not the due west day.
Right.
But he found that those ancient indigenous structures were aligned to this.
To the 12 hours.
Equal day.
No kidding. Who's that?
Hours. Gordon Freeman.
Gordon Freeman. I'll have to look that up. Look him
Canada
up.
Stonehenge. He's got a book out that explains it all in there.
Oh, that's cool. Thank you. All right, and thank you all. Thanks for being here. Thanks for being in Pennsylvania. All right.